Hello and welcome to Data Tiering Optimization. My name is Frank Riesner, and it's my pleasure to give you a session about this BW for HANA feature. A few words about myself. I graduated from a University of Bamberg in Germany, and afterwards started to work in the SAP BI environment. Since 2012, I am with SAP Switzerland, a senior solution architect for data warehousing. And I have also published books together with my colleague from SAP, Klaus-Peter Sauer, about BW on HANA and also BW for HANA in 2014 and 17. And yeah, I invite you to follow my blog posts on different modeling related topics in the SAP community. Let's start with a little positioning of data tiering optimization. If we compare BW for HANA, which was introduced end of 2016, to SAP BW 7.5, we see that there are quite some differences, but also quite some common features. Yeah. So in the first part, in the upper part here, you can see that in terms of data modeling and data integration, BW 7.5 covers many aspects of BW for HANA as well. There are, of course, the old interfaces or data models, but the new ones are to the most extent also available. In the lower part, you see some categories where BW for HANA has new features which are not available in the former versions, like the integration to the new HANA deployment infrastructure, also data protection and privacy, and the data lifecycle management. And I think data tiering optimization is a really good example of a value added by BW for HANA compared to the prior releases. And so we will focus in this tutorial on this topic. Of course, no presentation about this topic is complete without these general statements that, of course, information overall is growing in a very high speed, and organization collects more and more information. Also, data warehouses like BW, many organizations have the system for more than 10 years, for example. They manage large and growing amounts of historical data, and often it's not clear who owns the data. So there's no clear governance, and there's also not a clear responsibility. Or business is reluctant actually to make a decision to delete it. Yeah, IT has to govern it, to manage it, but business is often not interested in deleting data. The problem with that is that nowadays we have, well, in-memory appliances, databases, where the memory is the cost driver. Yeah, and this leads to a growing total cost of ownership of the hardware, of course, also of the licenses and of the operations of the whole system. And not only the cost, but also the pure amount of data in a memory platform, of course, has a negative impact on the system performance. So the solution for that is some kind of a strategy to manage your data, to have a sophisticated data lifecycle concept in place. And in our case, we structure the data in clusters, or here in tiers, regarding to their importance. These storage layers, synonym for tiers or clusters, they differ in the costs, but also, of course, in the performance they can provide. And also they need to provide options to scale on the individual needs for different lines of businesses or the whole organization. At SAP, we have this overall multi-temperature data management approach where we classify the most important, most current data which provides a high value for business decisions and requires a very high performance as hot. The warm tier is a less important cluster. It is still accessed, but not regularly. Maybe it's the prior year or the years before. And then we have a cold tier, which is rarely accessed, has a low value, and does not require a high query performance. Yeah, so an example would be we keep the current in the previous year in a hot environment. The warm tier is then the years before, and the cold tier is everything older than 4 years. Just as an example, because the time is a very popular characteristic for this kind of clustering. In BW for HANA, the concept, which I will refer to as DTO, is data tiering optimization. It's new with BW for HANA, and it's an overall consistent approach to manage the 3 temperatures of hot, warm, and cold data in one object in one place. So you can define all the data in an advanced data store object as hot, warm, or cold, or you can define partitions within that ADSO and define their individual temperature as well. Yeah, we will see this in a demo later on. DTO brings processes and tools to manage the displacement and the planning of these tiers and the displacement from one tier to another one. Yeah, you can, the typical approach would be that hot data is moved to a cold store or to the warm store, but also vice versa. Yeah, so if warm or cold data is required to be processed regularly, suddenly, then of course you can put it back to the hot store as well. What you also see here on this image is that we manage the hot and warm data inside the SAP HANA platform, while the cold data is physically managed outside of the HANA platform. So more details about these 3 tiers. As I said, hot is very important, has no restrictions to BW functions. The data is mission critical and is required for real-time processing. So it's kept in memory, that's the standard way, and is important for immediate consumption. It comes with the highest cost, but also the best performance. And within the SAP HANA platform, there's also 2 technologies to move the data from the HANA memory to a cheaper place where it does not have the same memory footprint. This is good for data which we don't need at the same frequency. It has still the same BW functions, but the data is not up to date and not mission critical. I will explain the technologies here, just to name them first. The one is HANA Native Storage Extension, or NSE, and the second one is called HANA Extended Node. Finally, the cold tier is for very exceptional access only. Normally it's read only, so the data is, well, not to be updated anymore, although if required, there is functions to do that. It's still available for reporting. That's the focus on the functions features. And the focus is to archive the data, historical data, on an easily scalable low-cost storage. In this case, or in our case of data tiering optimization, this is the cold store or external storage based on the SAP IQ database. In the following, I will introduce, well, these 4 tiers and the technologies behind that. And then we will have a look how BW for HANA is able to process these displacement and the whole concept. Well, let's start with the hot tier, which is the standard HANA memory. So without any data management lifecycle concept, without any DTO, all data is by default hot, is all managed in memory. So you load the data to the memory when it's required, and then the changes are periodically written as a backup to the persistence layer. In case of bottlenecks, the system will unload all the data from the memory in order to have enough space and to guarantee the stability. The default recommendation for an analytical system like a BW is to load only 50% of the memory with the data. So the real data volume should not exceed more than 50% of the available memory to leave enough resources for the analytical processing. However, as systems grow, many organizations cannot follow this recommendation anymore. So they manage systems where 70, 80% of the memory is actually loaded with a real data, and that leads to performance bottlenecks or even system breakdowns. And this, well, generates the need to have a data tiering optimization concept or something similar in place in order to manage the growth of the data in the overall system. The warm tier with a SAP HANA native storage extension, or NSE, is quite a new technology, and it's recommended for single node systems and available since, well, 2020 for BW for HANA. What is a single node system? So a system architecture can consist of several smaller nodes which work together and are managed by a master node, or you can have one big server which manages everything in one place. Well, in the past, HANA appliances had an upper limit of maybe 4 terabyte or 6 or 8 terabyte. Nowadays, a single node system can manage up to 24 terabyte of data, so the hardware limitations do disappear. And so most of the systems actually are single node systems. This NSE technology is a disk-based extension of the HANA memory, and it does not manage the data in memory, but in a buffer cache. Yeah, the buffer cache is also very fast in processing, but it's not available to the same extent in the SAP HANA platform as the HANA memory, of course. It can manage the warm data, and only the intermediate results or temporary data is actually managed in the memory of SAP HANA. NSE is fully integrated into SAP HANA. There's nothing to be installed in addition. So it actually works out of the box. There are a few parameters to set up the size of this buffer cache. Initially, it's set to 10% of the memory. And of course, if you use NSE to a large extent, then you should make sure that the system administration takes care of appropriate size of that cache. Yeah, but to start with and to test this concept, you're fully safe just to leave it with a standard configuration. The other warm option is for the so-called multi-node systems, so scale-out systems. So big organizations which started early with SAP HANA, they had no choice than to have a scale-out landscapes where several worker nodes work together, are coordinated by a master node, and the HANA extension node actually is just a definition to break this 50% rule of loading data and to define that one node can actually manage up to 100 or even 200% of data. That means there's a constant swapping from the persistence, and the system always loads and unloads the data which is required. Yeah, so we have a little example here. Let's assume we have 4 1 terabyte worker nodes. So those can then manage about 2 terabyte of data, of hot data. And then a 5th node would be available, which can manage up to terabyte of warm data. So we have in this platform a capacity of about 4 terabytes. 50% of the data is hot, and the other 50% would be warm. The extension node is also a part of the SAP HANA platform, so there are no restrictions in features or operations, and the data management is just like a standard node. You just have a performance disadvantage, of course, the more data you load into this extension node. Finally, let's talk about the cold tier. That's based on a SAP IQ database. Has quite a long history. Since many years, we offer nearline storage as an archiving option in SAP BW 7.3 and 4 and 5. And the same technology is actually used as a cold store for BW for HANA. There are some improvements. We use smart data access as a connections, and then some application logic is now pushed down to HANA. But more or less, we leverage the SAP IQ database for that. IQ is very good in compressing data, so we can manage a large amount of data. And on the other hand, also SAP IQ managed all data in column store tables, which is very good for the read access for analytical applications. Yeah, so the reading performance is actually not so bad. It's actually quite good. We will see this later on as well. When we move the data to the cold store, we actually replace it in the HANA database. So it's something similar compared to a selective deletion. Yeah, so it's physically not available on the HANA database anymore, and it's only managed outside in the secondary database. Well, in the past, SAP also offered cold store options based on Hadoop file clusters, which are, of course, still cheaper, but also do not provide a good reporting performance. However, SAP has stopped to invest in this direction, so all future investments focus on SAP IQ. There are quite many gaps in the Hadoop cold store, and so please refer to the SAP note, which is listed here. And well, we do not recommend that you start now a new DTO approach into this direction. Finally, the last point, cold data on IQ is still available for reporting for a BW query. There is a flag here in the query definition, which controls whether you would like to access the cold data or not. Yeah, here on the bottom right, you see that you can set it to read cold store or to do not read cold store. Now let's quickly have a look on slides how you set up data tiering optimization before we jump into the system. So first of all, when you model an advanced data store object, which manages your transactional data, there are, in addition to the standard modeling properties, also these data tiering properties. Yeah, so here you define which tiers you would like to use for the data in this ADSO. You see that hot, warm, and cold is offered, and the warm tier refers to extension nodes or to native storage extension. It just depends on which architecture you are actually running, and by default it will use then the proper technology. And the maintenance can happen on the object level. So the full data can be hot, warm, or cold, or on partition level. That means the data in advanced DSO is managed in different partitions, and each partition can belong to a different temperature tier. It's quite important that you make decision as early as possible, because when data is in your ADSO already, changes to these data tiering properties are possible, yes, but they are quite complex and they require expensive remodeling jobs. So it's much better to avoid this and to set this properly from the beginning of your design. So when the ADSO is set up and manage data, we use an app in the BW for HANA cockpit, which is called Manage Data Tiering, where you can define the temperature of all the different partitions of your advanced DSO. So we see here our advanced DSO has 3 partitions, one for 2019, one for 2020, and one for 2021. Currently, they are all hot, but you can plan the temperature for each of these 3 partitions individually. And as you can see, the oldest partitions should be moved to cold. The middle partition should be moved to warm. In this case, it's native storage extension. And well, the most current tier is still hot, so there's no change required. Yeah, so this is the design time. Here you plan the changes in terms of data tiering, and then afterwards you just execute the changes. The temperature change, as it's referred here, is executed as a background job in the BW for HANA server, and then the data is moved from hot to warm, or in our case also from hot to cold. Quick overview of the demonstration I would like to provide to you. So we have an advanced data store object which manages purchasing data for 3 years. Equally, there are about 1.8 billion records for 2019, 2020, and 21. Initially, all the data is managed in memory and consumes about 80 megabyte of memory. And then we have a concept to move the oldest partitions to the cold store of SAP IQ and move the previous year to the warm store. So when we implement that, as you see on the right here, partition 1 is deleted from the SAP HANA platform and is moved to SAP IQ. And partition 2 is removed from the HANA memory, but is moved to the buffer cache of the SAP HANA platform. And then, of course, after these changes, you are able to see the impact of the consumed memory in the overall HANA platform for this one object, for all the about 6 billion or 5.5 billion purchasing records. Okay, so I will leave my presentation and I will go to my system. This is BW for HANA 2.0 SP7. Here we see the BW modeling tools. I have a advanced DSO, which is of a type of data mart, so similar to an InfoCube. And here on the right-hand side, we see the data tiering properties. So I have enabled hot, warm, and cold, and I manage the temperature or the whole concept on partitions. That means I have to set up partitions in order to make that happen. So in the settings of this object, we see here on the top that we have partitions on a calendar year field with the same granularity. And in this case, I used dynamic partitioning That means I loaded all the data at once, and for the 3 different values for the calendar year, value 1 is 2019, then it's 2020 and 21. Individual partitions are created on the database in the active table. Yeah, in the active table, that's important. So it's not enough to load this cube-like advanced DSO. We also have to activate the data, so compress it in order to get it from the inbound queue to the active table. If you have a look at that active table, yeah, so that's the table 2 of that ADSO ZDTO underscore A01. We see the system has set up by default these 3 range partitions for the 3 years. You see the record count. They are almost equal with 1.8 billion records each. And each of them are fully loaded to the memory and, well, consume more or less 27 to 28 megabyte of data. So the overall consumption is about 84 megabyte of data. And we will have a look at this view later on when we move the data to warm and cold, how the impact is on the overall memory consumption. Okay, so I have set up my object properly. The design time here is okay. The object has data. Now I will go to the data tiering app in the BW for HANA cockpit. My ADSO is selected. I see that about 80 megabytes are consumed and only in the hot store. Now let's go to the design time and plan the individual changes to the partitions. For the partition 1, 2019, I would like to plan the temperature to cold. Yeah, current temperature hot, plan temperature cold. And well, then for the warm tier, I will do it afterwards. So let's go back one step. Let's select the ADSO and let's, well, execute this change to the temperature. Immediate start. And now we see there's a job scheduled to actually copy all the data, which is part of that partition with calendar year 2019, copy the data to the SAP IQ database, which is connected to the HANA platform. And then in the end, all the data is deleted from the HANA platform. Yeah, so now this is in process. And as long as this is in process for about 2 to 3 minutes, I will show you the query which I've defined on this object. Yeah, so here's a simple query, DTO query. Here in the end, you see that there is actually this flag, do not read cold store. Let's leave it like it is right now, and then change the value later on. There's a filter, of course, on the calendar year, which is a variable. And then we have a sheet definition where we have a few key figures. So the gross order value, the net order value, and the quantity. And then we break it down on product IDs, on the supplier, and the approval status of that purchase order. Yeah, so now I go to the SAP GUI where I can actually measure the runtime quite well in this query monitor. So that's this transaction RSRT. This is my query, and let's not use the cache and display the statistics data. For the year 2021, so the hot data, I will now measure the runtime. The result for all the 3 tiers will be the same. Yeah, there will be 5,085 pages of this result. But actually, the result is not so important. The duration or the runtime of this query is interesting. So the overall runtime is 10.2 seconds, and then we have to subtract this waiting time at the beginning. So it's about 1.7 seconds, the whole report on the hot data. Yeah, it will maybe be 1.5 or 1.6 if we repeat this equally afterwards. So it's in that range. Okay, having said that, let's hope that my process is coming to a finish. Great. Yeah. So now the data is actually on the cold store. You see now the current temperature and the planned temperature is equal. We have cold and cold for the year 2019. And well, before I refresh, before we had here this number of records in the range partition for the year 2019. This is the view on the HANA database. After refreshing it, the value will be 0. Yeah, so record count 0 records because they have been selectively deleted from this ADSO after they have been successfully moved to the external storage. And the total size was 26.7 megabyte before, has dropped to almost nothing. Yeah, some metadata is of course required because the ADSO well knows that the data is managed outside and the connection is done based on smart data access and virtual tables. Yeah, and the total memory consumption has dropped from 84 megabyte to 57 already. Okay, so now let's focus on the warm tier. Yeah, the year 2020 should be moved to the warm tier. That means it's still in HANA, so the record count will be unchanged, but the total size in memory will drop. Okay, so this is my partition for 2020. I plan the temperature to warm. Current temperature hot, planned temperature warm. Now let's execute this as well. Let's give it a minute or two to run. And well, in the meantime, we can check the runtime on the cold data. What do you think? Yeah, so we have moved partition for 2019 to the cold store. Now let's run the query on the cold store for 2019. And it will not bring any data because the query is defined to not read the cold store, right? You remember that flag, which I highlighted at the beginning. In the general overview of my query, the cold store access is switched off. Let's switch it on. And now I will re-execute the same query again. Without cache and with the statistics data to see the runtime. So 2019. Now I will get a result, the same set of data, all my 1.8 billion purchasing orders. And the runtime is collected right now. Yeah, the runtime is about 10 seconds and we subtract 3.8. So it's about little more than 6.2. Yeah. Remember we had about 1.5 to 2 seconds for the hot store. Here we have about 6 to 6.5 seconds. Yeah, so maybe let's just repeat the same to be sure. Yeah, it's the same. Now we have a total runtime of 8 and we subtract 2.6. So now it's actually a bit better. Yeah, it's 5.5. Yeah, let's say it's 5 to 6 seconds. The response time for the query on the cold store. Okay, so in the meantime, surely my job to move the data in the buffer cache from the hot memory is done. We see here all the planned temperature equals the current temperature. And now let's go back to my memory consumption. Yeah, so I expect that this number of 28 megabyte total size to be dropped. And well, it drops to about 6 megabyte. Yeah, we still have the same amount of data in the HANA platform. It's still on a HANA database, but as it's not in memory, but in a buffer cache of NSE, we don't consume 28 megabyte anymore, but about 6 megabyte. Yeah, so we have come down from 84 to 35 megabyte of data. Now this is some remaining memory with this object consumes, and it also varies. Yeah. Now let's of course check the runtime for the warm store. So let's execute the same query for the year 2020. My runtime is, well, about 1.7 in this case, quite good, almost the same as the hot tier. And in HANA Studio, well, this number has increased a bit. So the rule of the thumb is that about 60 to 70% of data is freed up and the remaining data is still partially loaded to the memory. These are temporary results and some meta objects to ensure the connection from the warm store to the hot store, where finally, well, the OLAP engine analyzes and calculates the query results. Okay, so just to be sure, let's execute the same query on the warm data again. So it's about 2.6 seconds, yeah? 4.6 less 3. So it's about 2 to 3 seconds in this case. Okay, so back to my presentation. What we saw is a partition in the hot store consumed about 28 megabyte. When we move it to warm and work with it, then it consumes about 60 to 70% less, so about 10 megabyte. And if we define it as cold, it is almost nothing, yeah, 0 megabyte. From the query runtimes, the query on the hot partition is about 1.5 seconds. The warm access is a little bit worse, but not considerable. And the cold access can be switched on or switched off. Is still quite good, and is about double of the runtime of the hot store. I would like to close my presentation with a little outlook. So SAP Product Management plans to enhance this data tiering concept. In the hot store, the persistent memory is already introduced. From the warm store, native storage extension has been introduced last year and maybe might also be an option for the scale out architectures. The extension node is still offered, but is not so much in use as of today. And the cold store, well, relies on SAP IQ. Remember, Hadoop is not recommended anymore. And the SAP HANA data lake is planned as a new option, which also relies on the IQ paradigm and technology. But here you have IQ as a service, so a subscription model in order to move your data and archive it to a cheap location. Finally, some good sources to deep dive into data tiering optimization. So here's a presentation from the product management and the blog. Also in the help portal of BW for HANA, there is quite a lot detailed documentation. And this is there's also a good subnote which gives a good introduction. And then for all the different tiers and technologies behind these tiers, there are some good, well, white papers, guides, and important notes to be considered. Thank you very much for your attention, and have a good day. And thanks for attending this webinar. Bye-bye.